Example one, we have a word problem that kind of involves factoring. So what we have to understand for factoring is that when you factor something, you turn it into a multiplication problem. So if I take this problem, which is 10x plus 5, and I factor it, I would get 5 times 2x plus 1. This is a multiplication problem. It can be thought of as 5 times 2x plus 1. So when you factor, you are doing the opposite of multiplication. You are dividing. So if I take our problem here, for example, 1, we have a soccer field. And this soccer field has an area of 240 minus 400x. All right, so our area is an expression. And then you have your length and you have your width. All right, and we want to find a width. So we want to find a width, and it says the width has to be at least 60 yards. So this has to be, if I write it this way, the width has to be greater than or equal to 60 yards. And that's according to our problem, right? It says at least 60 yards. So anybody, what is the equation for area? Area equals length times width. It's L times W, right? So without even plugging in numbers, right? Using just our expression, using just our variables, if I am given area and I'm trying to find width, what operation would I be doing? Division, right? Because when you're given area, so for example, let's say I take another rectangle. Let's say my rectangle has a length of 10 and a width of 50 and 5 and an area of 50. I would know that area equals 10 times 5. But let's say I didn't know what 5 was. Let's say it was just x, right? So it would be 10 times the letter x. How would you figure out what my x value is? You would divide 50 by 10 and you would get 5. So I know that if I'm given an area, I need to divide to find my width. All right, and it says it has to be greater than or equal to 60. So it can't be less than 60. So how do we divide expressions? Is it distributive property or is it factorizing? Factorizing, right? So we're going to take our expression right here, which is our soccer field, and we need to factorize it. So what can I divide? Whoops. Oh, my pen's doing that. What can I divide 240 and 400 by? Can it be divided by 60? It can't be divided by 60. Why would 24 be a wrong answer? What does the width have to be? We have to divide by something that is either greater than or equal to 60, which means anything below 60 doesn't count, right? So think of it as the greatest common factor. Yes, you can divide by 8. That would work. Yes, you could divide by, I believe you can actually divide by 16. Let's try 80. Would 80 work? Is that our highest common factor? Is there anything? So you can't do 90. You can't do 100. You couldn't do 120. That wouldn't work.
Wait, no, 112.
You can't do 112. So does 80 seem like the highest number? All right, yeah. So we're just basically factoring by the greatest common factor. We can cancel out these zeros. So if I factor by 80, what's 24 divided by 8? That's a math fact. 3. And it's going to be minus 40 divided by 8, which is 5x. Right? So I factored it. And we want to look at it a different way, right? So I know that the area equals 240 minus 400x. Okay, so we have to look at it as an area problem. This is your area, right? That's your area. one of these is your length, and one of them is your width. They're interchangeable, right? You could write the rectangle like this, with your length and your width, or you can write the rectangle like that with your length and your width. But what you have to understand for your quiz, and what you have to understand is when you factor, you're basically breaking it up into a math problem. The best way I can describe it is, hey, let's factor the number 24. You can break it up into 6 times 4. So when I take an expression and I factor it, I'm just breaking it up into a math problem. I'm given area. If I factor it, then I will find my width and my length, because I know that area equals length times width. You're taking a multiplication problem and you're breaking it down. It would be the same way. This is the same thing as if I have a rectangle and I say the area is 60. This length is 6. Nope. This width is 6. What would my length be? 10. How did you find that? Because you divided. So what we also have to be able to do is, what if our area, just like our problem, is an expression, right? Well, then I'm just going to go ahead and divide each by 60. So I know that this side, not 60, I'm sorry. We're going to go ahead and divide by 80. So this side is 80. And then whatever I factor ends up being, what was it, 3 minus 5x?
Yeah.
And if this is correct, then if I multiply my length times width, what should I end up with? I should end up with my area, because length times width is area. So if I multiply 80 times 3 minus 5x, I should get this right here. 80 times 3 is 240. 80 times 5x is 400x. So if I distribute, then that means it's the same answer. So again, factoring is dividing. Distributing is multiplying. And you're just breaking it up into multiplication problems. Let's go to example 2.
Wait, so the answer is
The answer would be what you factor out. Yes. Your answer is 80. Your answer is 80 because that's what you factored out of it. You're looking for what you factor out. All right, example 2. Example 2, we have a pool. It has a width of x and a length of 2x plus 3. And we want to write an expression for the perimeter. So right off the bat, what is perimeter? Angie? You're adding them all up, right? So perimeter is length plus width plus the other length plus the other width. Well, if the top part is 2x plus 3, what's the bottom part? If the top part, it's the same, right? It's 2x plus 3. And if my left side is x, then what's my right side? It's also x. Now, if I'm trying to find perimeter, what do I just do? I add them all up, right? So, perimeter can also be expressed this way, 2L, because you can combine like terms, and then plus 2W, because you combine like terms. So, perimeter can be looked at different ways. But if I just kind of go ahead and perimeter equals x plus x, so I got my right side and my left side, then I add 2x plus 3 right here, and then I add 2x plus 3 up here. I have this nice fancy expression. I can go ahead and combine like terms. So how many x's do I have?
A lot.
Yeah, I got 1x, 1x, 2x, 2x. When I add all those up and combine like terms, what do I get?
4x, 2x.
Nope. We want to combine, we're combining this x, this x, this x, and this. So yeah, we're going to add up to 6x. And then we can't forget our other terms. When we combine those threes, what do we get? Plus 6. All right. So according to our problem, it says, write a factored expression for the perimeter. Do we have a factored expression?
Yeah.
No, wait, no.
So do we have an expression?
Yes.
We have an expression. Is it factored?
No.
No. It's not factored. So how would I factor this equation right here? And then again, factoring, is it multiplying or dividing?
Divide.
Dividing, yes. So I'm going to divide both of these terms by 6. 3 would work, but you want to go the highest common factor. So if I divide by 6, it's going to be equal 6 times the quantity of what goes in the inside of my parentheses.
Plus 1.
X plus 1. And this would be your factored answer.
How'd you get all those like little numbers?
What is a quantum?
That's all that is.
What is it for quantum? What you said?
So you guys know how you don't, I got you, Zaina. So you guys know how you don't know how to say this with words? Like, how would you say this? Yeah, how would you say this answer with words?
Factorization.
No, like, give me, like, what is this answer? Like, read it left to right. What is the answer?
6 times x plus 1.
It's actually 6 times the quantity of x plus 1. Quantity of means there's parentheses.
Can I?
All right, so Zaina, you asked, how do we get our long perimeter equation? Well, I have my equation for a perimeter. It is length plus width plus length plus width. Well, what I have over here is I have length, width, and width. So I added all these up.
Oh.
So you have both of your x's, so you write x plus x, and then you have 2x plus 3, so plus 2x plus 3. I still have to add this 2x plus 3 plus 2x plus 3, and now I've accounted for everything.
And then.
Do you see where you got that from?
Yeah.
All right, cool.
After all,
Yeah.
That whole equation, you're just like adding.
Yeah.
Combining like terms.
And you would get 6x plus 6,
And then you factor.
and you factor it, and you get 6 times the quantity of x plus 1. Or you could say x plus 1 on the inside of the parentheses multiplied by 6.
How did you turn 6x plus 6 into 6x plus 1?
You divided,
1 in that problem.
you divide both by 6, correct?
Yeah.
So this turns into
1x plus 1.
1x, and 6 divided by 6 is 1. And on the out, why do we put the 6 on the outside?
Because that's your.
Yeah. So do you see how we got the 1? Awesome. Okay, last example.
Wait, couldn't you just do 6 and then 1x?
No, not 1x. Oh, yes, that is, yes, that is correct. Oh, you have to add it. I'll show you why. Because if you have, that's a good question.
Why did you put x plus 1 instead of just 1x?
I'll show you. This was our original equation, right?
Yeah.
And if we factor it, we would get 6 on the outside with x plus 1. So you're asking why we can't just do this?
Yeah.
All right. When we distribute, right? When we distribute, it's supposed to equal the original equation, right? Because we're not changing the value, right? It's like me saying 24 is equal to 6 times 4, right? They're the same thing. If I tell you, Sydney, I have 6 times $4, how much money do I have?
You have 6 times $4.
Yeah, I have $6 times 4.
24.
I have $24, right? So it doesn't change the value. So, Sydney, I want you to go ahead and distribute the bottom equation right here. What is 6 times 1x? 6x. All right, now distribute the top one. It'd be 6x plus 6, right? So do you see how this one doesn't match the top, but this one does? So that's why you have to add 1. It's because you're accounting for that constant. All right, but let's go to example 3 so you guys can get your quiz. So example 3. Boys, figure it out. Yeah. All right, so example 10, it says lists or check mark all of the options that are equivalent to my original expression, okay? What I want you to notice about all of our answers, A, B, C, D, E, they are all what? They're already...
Factor.
Yeah, all the answers are already factored. Now, let's take a look specifically. I want you to take a look at option D and option A. What is unique about option D? What makes them different? And actually, specifically, option A and D, let's look at what's on the inside of the parentheses. What is wrong about A and D? Not wrong, but what is different about A and D?
A has,
Let me reword the question. A and D, are they completely factored? No. And here's why. I can divide both of these by 2. I can divide both of these by 6. So, whoever factored A and D, who threw that? That's a mark. All right, so whoever factored A and D didn't factor them all the way. So, if we were to factor our original expression, it may not give us a complete answer. What the heck's going on there? My Y is off. Why does that look weird? There it is. Okay, cool. So, in order to solve this kind of problem, because they didn't factor every single option for us, is we have to use the distributive property and we have to expand all of these fractions. So what I want Marina, you're doing letter A. I want you to expand A. Zaina, you got B. Ambrose, you have C. Mark, you have D. You have to expand them. And then let's go with Audrey, you have E.
to see if it equals the 12 point.
Yeah, so basically you're going to distribute to see if it equals this option. Boys, focus up. Awesome. So let's go with Ambrose, letter C. What did you get when you distributed?
12 plus 35.
All right. Is that a correct answer?
Yes.
Yep. Let's go with Mark. What did you get for letter D?
12 plus 60y.
Is that a right answer?
No.
No, it's not. Let's go with letter A. Marina, what did you get?
12 plus 30y.
Is that a oops? I messed up. So yeah, Marina, is that a correct answer? That is. Let's go with Zaina. What'd you get for B?
12 plus 40y.
Is that a correct answer? No. And then Audrey, what'd you get?
I got 18 plus 6.
Is that a correct answer? No. So our correct answers are C and A. Yes. All right, so I need a volunteer to collect. All right, so Ambrose, what I want you to do is I want you to collect all of the note packets if and only if they have their name on it. So if they don't have their name on it, don't take it. You guys clear for your desk. You guys have a quiz.